Let me introduce Dr. Diana Gragg. She is the Managing Director of the Explore Energy program at the Precourt Institute for Energy here at Stanford. Explore Energy is a student engagement program, and it's helped students navigate just the variety and number of opportunities, including courses, majors, internships, job opportunities that are related to energy across all of Stanford's 7 schools. In addition, I feel like she kind of teaches the class version of that, which is Understand Energy. In the fall and the spring, we'll learn a little bit more about it, but from what I understand is kind of a broad overview of energy from a lot of different perspectives, including policy perspective, including economics, including science. And so she sort of sits at the web of all these different opportunities and teaches this course that sort of explores energy from all these different angles. And she is very well qualified to do that. So Dr. Gragg's background is she has a bachelor's degree in chemical engineering. She has MS and PhD degrees from the Atmosphere Energy Program in Civil and Environmental Engineering here at Stanford. But in addition to that, she was a Schneider Fellow at the Natural Resources Defense Council in DC. She worked at the Dow Chemical Company as a production engineer and as a project lead on energy efficiency projects. And she was a postdoctoral scholar here investigating different areas of sustainable transportation, excuse me. So she's done a variety of things, and she brings that really valuable perspective to this particular challenge. Now, today she'll be talking about the accelerating energy transition. And again, we're really excited to have you here, Dr. Gragg, and we look forward to learning more about it.
Awesome. Thank you so much, Pax, and thank you for that introduction. So welcome, everyone. I'm really happy to be with you here today, talking about the accelerating energy transition. So I got a nice introduction, so we'll skip that. And really today I want to explore with you where our energy comes from today, talk to you about what do we mean when we talk about energy, why we care about energy. So I'm going to list some of the reasons that we think we should care about energy, and you can think about your own reasons about why you care about energy, and some of the exciting things that are happening, which we're calling here the accelerating energy transition. There's a lot of drivers for energy transition. We'll talk about those when we talk about why we care about energy. And it's really an exciting time in the energy industry. I would say there's a lot of aspects of the energy industry that have been doing the same thing for a long time. But now here we are today, we are making dramatic changes in a lot of our energy industry. So it's a dynamic system that is changing a lot. And so that can be pretty exciting. Okay, so first I want to just give you a landscape. What do we mean when we talk about energy? So when we're talking about energy, we're really talking about what do humans want? We want energy services. And that's where we should start when we're thinking about energy. We as humans, we want heating, we want cooking, we want lighting, we want transportation, we want our cell phones charged, our computers charged, we want our comfort in our spaces. Those are energy services. And there's a number of ways to get those energy services. And so what we do is we take the energy resources that exist. Those are our primary energy resources. That's our fossil fuels, the sun, the wind, things like that. We take those primary energy resources and we have to convert them to get the energy services we want. They don't often exist in the ways that we want them for our energy services. And so the way we do that is through secondary energy or energy currencies. And so that's things that you're very familiar with, like electricity, like gasoline for your car. Those are energy carriers. We've taken that primary resource, we've converted it to something that is more useful for our energy services. And so that's the landscape we're talking about. I added another box on here talking about energy storage, because especially for something like electricity, we have to match when we want those services to when that electricity supply is. And so we have to think about how do we store, how do we make available some of these energy services when we want them. And so energy storage is an important aspect of that. Okay, so I also want you to think about, now that we've kind of framed what energy is in terms of this, providing these services that humans want, I want you to think about energy in terms of a system. And this is going to be important as we're talking about transitioning to a different energy system for the future, we have to think about this as a whole system. And so on here, I've put these are the two largest energy systems in our world today. We have oil providing transportation services, and we have coal providing other electricity services. And so those are still today the two largest energy systems we have in the world. And there's a lot of different steps in these energy systems. So you can see the primary energy is the energy that we have. Those are our resources that we have on our planet. We convert them to something that's more useful. Taking the coal example, we're putting it into an electricity generation. This is where a lot of the efficiency loss happens in this system. And so when we're putting coal into that power station, we're only getting about 1/3 of the energy out as something that's useful. This is a significant energy efficiency loss in the system. We're making it into electricity, and then we're providing the electricity service that we need. So when we're looking at these two largest systems, I've put kind of this triangle to think about the efficiency of these systems. So if we're putting in 100 units, to think of those units as any sort of energy unit of that resource in this system, we're only getting about 1 to 10 units of energy service out. And that's because of these large losses in this system. For the oil system, a lot of the losses happen right in our automobiles, where we're actually putting that oil in as a heat engine in a very inefficient manner. And so as we're thinking about how do we provide these human services that we need for the future by using less of these energy resources, the first thing we need to think about is how to make these systems and provide these services in a more efficient way. So that's just framing how to think about energy. So I want to give you a sense of where we're at today. What is providing our energy needs today? And so I've got 4 pie charts up here showing both the resources that provide our energy overall, and then a subset of that, which is just electricity generation. And I'm showing it for both the world and the United States, and both of these. And all of these, you can see that fossil fuels really dominate our energy system. Probably not a surprise to anyone, but it dominates our energy system and has for a long time. So you can see for energy, we're around 80% of our energy is provided by fossil fuels. Electricity, it's more like 60% of our systems are provided by fossil fuels. The biggest difference when we're talking about energy to electricity is transportation and also industrial heat and other heat needs. So you'll see in our fossil fuels, really, we don't use oil for electricity. We primarily use oil for our transportation systems. So you see oil is almost 0% or 2% in both of our electricity charts. Only really using oil for electricity in places where it's hard to have other resources, like island nations, for example, might use oil for electricity. Otherwise, oil is a very high energy dense fuel, both from a volume standpoint and a weight standpoint. And so it's actually been really effective to use as a transportation fuel from that point. And so that makes it really hard to find other uses or other fuels to power a transportation system. And so as we get into this and as we start talking later in today's lecture about decarbonizing our energy system, this gives you a sense of the challenge of that. Oil is in particular is a really tough challenge because of that energy density of oil. Okay, so that's giving you a snapshot. I also just wanted to give one example of over time. So this is the United States electricity sector since 1950 to today, and showing you what we were really relying on for the electricity demand at the time. So that's 100% is our electricity demand. And you can see over time, we have really weaned ourselves off of oil for any sort of in our electricity system. A lot of that was caused by policies after the Arab oil embargo in the late 1970s, which really made oil just too expensive to use for electricity when it was so valuable for a transportation fuel. And then you can see our coal system here in the United States. Coal is really on this fast decline, really peaked in 2008 and has been on a decline ever since in our electricity system. And that is really because even existing coal-fired power plants cannot compete with new wind, solar, and natural gas power plants, both on a cost standpoint and in dealing with a lot of the waste streams that come with coal. With coal, you have to deal with coal ash out the back end of a generating station. You have to deal with mercury and sulfur emissions out the stacks. Natural gas, wind, and solar don't have some of those challenges. And so coal has really been on this decline as natural gas, wind, and solar have really been more cost effective, in addition to policy encouragements. But even on an unsubsidized manner, wind, solar, natural gas are cheaper options and are becoming to dominate our electricity system. Nuclear and hydro haven't changed a lot, but nuclear is also on the decline. Again, it also is having trouble competing, even existing nuclear, with new wind and solar because they've become such a low-cost electricity source. So we're going to see renewable energy growing more, but you can see, and it's growing quickly, but you can see it's growing from a pretty small amount. So this is a long way from really being a decarbonized system. We're still, 60% dependent on fossil fuels. Okay, so that really gives you a sense of where we are today. I want to talk about why we care. Why do we care about energy from all these different aspects? There are economic reasons that we care about energy. We need those energy services and we want them to be cost-effective ways to get those energy services. There are political reasons we care about energy. We think about energy security, foreign policy, security and stability. There are environmental reasons that we care about energy. So climate change, air pollution, other environmental impacts on our water systems, things like that. That's a reason we care about the environment. Ethical reasons, so human development, equity are reasons we care about energy because it's so key to those energy services we need. And then, medical access and diseases. And I think this was really highlighted with the COVID pandemic. We've really seen some of the importance for energy in terms of medical access and how important some of the aspects of that are, in addition to some diseases spreading from climate change. So all of these are reasons we care about energy. And so I'm just going to give some examples in these categories of why we care about energy, why it is so important. I'm going to start with economics and energy security. And so one of the framings we talk about when we're talking about the impacts of something is social costs versus private costs. So private costs are what we pay for the gallon of gas, what we pay for electricity. That's our private cost. The social cost is the private cost plus any externalities for using that resource. And so an easy example is, for a gallon of gasoline, I'm paying, $3.50 for a gallon of gasoline. The externalities of using that are air pollution, are climate change. And so society is bearing some of those costs that aren't included in the private costs. So that's the social cost. And so this is just an economic framework and thinking about that. And a lot of times our policies are meant to try to incorporate more of those externalities into the private costs. So society isn't bearing those costs. And so it's a way to go back and forth. And so I like to use this cartoon to kind of show an example of this. And so this cartoon, the person's come up to the gas station to buy a gallon of gasoline, which is $1,000 a gallon. And the person's saying, well, the gas is only, $3, $4, but there's this military aspect. There's these additional social costs associated with that gallon of gasoline. And so that is this framework. And then we think about how can we more accurately price some of the private costs and how can we do that in an equitable manner, and that gets challenging. And so some of the externalities for this example, for oil, there's the military aspect for access of oil, especially when it's so important to so many economies around the world. There's air pollution, water pollution, there's land use, there's climate change aspects of our oil use. And then there are taxes and subsidies associated with this. So although thinking about this in this framework, it might make sense that we were trying to incorporate externalities into private costs. That's not always the case. Some policies actually lower private costs, and then society is bearing more of those externalities because the commodity isn't accurately priced. And so there's some things like gasoline taxes that move those externalities into private costs, and there's some things that are more about like here in the US, we have subsidies to try to encourage domestic oil production, and that's more from an energy security standpoint. And so some policies are kind of moving this in both directions. So just to give an example of one reason we care about energy and our systems is it's important in all these different aspects of our lives. I'm going to continue on the oil example because I think it's pretty illustrative for another reason we care about oil, our energy systems, and that's foreign policy and trade. And this one comes up a lot. A lot of people are surprised to learn that Canada is actually the country that the US imports the most oil from. And that's because a lot of the energy security concerns that come up around oil for the United States often have to do with OPEC countries, Saudi Arabia, Russia in particular, most recently. But it definitely complicates foreign trade and policy. And so it makes it challenging, I would say, for for governments when they have a resource that's so important to their economy and they're dependent on it from other countries, it really complicates those relationships. And so we see that a lot when with Saudi Arabia being really a swing country in terms of oil production and oil price, that impacts how, for example, US governments and US presidents might interact with Saudi Arabia. And so certainly this kind of dependence is another reason we care about foreign policy and trade is another reason we care about these energy systems. One of the things I like to point out is, we get a lot of at least our imported oil from Canada, generally considered a friendly country with the United States. But it is also a very carbon intensive and land intensive type of oil. Much of the oil coming from Canada is in oil sands, or sometimes called tar sands. And so what we're importing from Canadian oil often can have just an increased carbon intensity and environmental impact than other places. So another aspect and reason we care about energy. Okay, I think one of the reasons we care, and then we're just following on the geopolitics of this, and I think this has been highlighted a lot with Russia's invasion of Ukraine. Europe has long depended on Russia for much of its natural gas. This is just giving you a sense of how much the European Union has depended on Russian supply of natural gas over the years, starting in 2001, around 30%. Got up to a peak around 2018, 2019 of over 45%. And then you can see the major drop through concerted efforts on the part of the European Union after Russia's invasion of Ukraine. And so Russia has used this reliance on natural gas as a power play in terms of impacting policies and things from that international relationship. And so again, energy is important because it has not only these important parts of our energy services, but these geopolitical challenges as well. And certainly the invasion of Ukraine was not the first time that Russia has used Europe's reliance on its natural gas as something to try to influence policy between Europe and Russia. And so we've seen, I've marked some of these places where they've cut the gas to Ukraine, for example. as a political tool. So this is just another reason that the energy systems are really important, and it gets complicated. I'm going to switch gears a little bit from geopolitics to talk more about equity and human development. So another reason we care about energy is the global energy consumption for modern sources of energy are highly inequitable. There are countries that have a lot of access, like the United States, to modern sources of energy and have for a long time. And there are other places in the world where this is very limited. And so what I'm showing you here is primary energy consumption for different countries, and then trying to give you a sense of some of these countries on how that relates to their population. So you can see United States, we have about 4% of the world's population, use 16% of the world's energy. China, which has had a lot of energy consumption growth as its economy has grown, has 18% of the world's population, uses about 26% of the world's energy. And then places like, oops, I'm not sure what happened. Places like Africa have 18% of the world population and use a very small portion of the world's energy. And so it is highly inequitable in terms of access to energy, and that has impacts on human development and economic activity. And so this is another reason, if we're worrying about human development worldwide, globally, this is another reason we care about energy. One of the measures that we use to look at human development is the Human Development Index. And that access to modern energy is really important. It's highly correlated with income and quality of life, especially on the low end. And so if you're looking at this chart, and I apologize if it's a little small, but on the y-axis, I've got Human Development Index. On the x-axis, I've got electricity use per capita. And so you can see, if you kind of just glance down a lot of these countries, to really get up the Human Development Index on the left-hand side, you really having a little bit more access to electricity as a modern energy resource really helps you move up the Human Development Index. At some point, you get to the point where you're in this kind of developed world category, and you can see there's a wide scatter of electricity use per capita, but many of these countries, that additional electricity use doesn't actually lead to an increase in human development. And so this chart is telling you two things: that on the developing side of things, access to modern energy resources is really important. And it's also telling you that for the developed world, there are likely more efficient ways that we can use our energy access and maintain a high quality human development. And so both of those things really need to happen as we're looking to transition our energy systems into the future. Another reason we care about energy is the environmental and social consequences and other ethical issues. And so the first thing I'm showing you here is that we care about and we impact environmental and social parts of our planet on all parts of our energy systems. So I showed you energy systems earlier. And so we have everything from the resource to the service, from extraction of the resource all the way down to what we want as humans. There are impacts on this whole system for many of our energy resources. And so there are land use impacts for our energy resources. We care about the water, contamination, availability of water, how we're using water, atmosphere. So both air pollution and climate change are significant impacts. We'll talk a little bit more about air pollution and climate change next, because those are significant both locally and globally. Wildlife. So as we have land use change, we have habitat encroachment and destruction, species extinction that we worry about. Health and safety. So from a human standpoint, a lot of the extraction, especially businesses, sometimes the refining businesses, can be more dangerous or have more risk that has to be managed. And so that is a challenge with our energy use. We get, I put it as this category of annoyance, but there are definitely, we call them NIMBY issues, not in my backyard issues, with a lot of our energy use. So that is a social impact from our energy use. And those are just categories, but there's also long-term impacts. So intergenerational. And the big ones, I think I've listed kind of the big ones here. Climate change is one we're going to talk about more. Nuclear waste is another one that we have not resolved. Radioactive waste from our nuclear power plants is radioactive for 200,000 years ish. And we don't have long-term solutions on keeping people safe for that kind of time frame. And so those are unresolved issues with the energy systems that we have today. And then finally, there's environmental justice. And so I'll give an example of that next. But thinking about energy equity and environmental justice, there's a lot of ethical issues on how we've extracted our energy resources, how we're using them, and who is bearing more of the social costs of those energy services. And so those are all challenges that we see and reasons we care. So just to give an example of that last one, I'm talking about air pollution. So air pollution is more deadly than people often think. So globally, air pollution kills an estimated 7 million people in the world. Here in the United States, it's around 100,000 people every year have premature mortality because of air pollution. And those effects are felt disproportionately by different people. And so this is a Harvard study that was done in the United States that, basically Black people were 3 times more likely to die from exposure from airborne pollutants than other groups. And it's inequitable. So what this chart is showing you on the left is the air pollution emitted, meaning what benefit did they get from the energy service being provided from the air pollution that is being emitted. And on the right is the air pollution that is being inhaled by those populations. So just to show you that it's disproportionate for these different groups in terms of how much impact they're getting compared to the benefit that they're getting from the services. And so there's a significant energy equity challenge with the energy systems we have today. And leaving the biggest, I would say the elephant in the room to the last on our reasons we care about energy, talking about climate change. So energy is the biggest piece of the pie of what is contributing to greenhouse gas emissions and climate change. And so this is in all sorts of different sectors. This is kind of broken down into transportation, industry, use in buildings, different ways to look at it. But energy is the biggest piece. And so it is a reason we care about energy. And of course, we are constantly seeing, I would say more and more each year, the impacts of climate change. And so these are just giving some examples. We see record heats, we see wildfires, we see hurricanes. Most recently here in the United States, and in North America, we've seen the wildfires in Canada, where it is unprecedented, and we keep hearing that unprecedented, wildfires or storms from climate change. And so I'm showing you here what the wildfires look like this year for Canada and how that impacted the Northeast. So this is showing the skyline of New York, kind of on a normal day, and then during when the wildfires, smoke was being blown in from Canada. And so on climate change, it is one of those long-term legacy intergenerational challenges with our energy system that we're seeing the impacts of today. And when we're talking about equity and justice, a lot of the communities that are going to have the hardest time dealing with the impacts of climate change are the ones that don't have the resources to do so. And so a lot of this is a major challenge to our energy systems when we're talking about maintaining our planet for human life. And so I'm giving you this. This is a chart from a Stanford group showing the global carbon project. So you can see more at that website if you want to dig into the data a little bit more. But we really have a carbon budget, and if we want to keep from going over this 1.5 degrees Celsius that we hear about in the media, we hear about from the IPCC, we're about at 1.1 degrees Celsius now. We have a very little time to get to a zero carbon or even a carbon negative energy system. We are going to run out of that budget in the next 10 to 20 years. And so this is a very urgent need for transitioning our energy systems. Okay, so that is some of the reasons why we should care about energy. And hopefully you've thought about yourself why you care about energy and what aspects are most interesting to you. The last little bit of today's webinar, I want to talk about how things can change and how things are changing. Because I mentioned, our energy systems for a long time weren't changing a lot. And in the last couple decades, they've really seen shifts and all sorts of different aspects on how we're supplying the energy services people need. And so this is just one estimate of what it will take to finance the transition to net zero by 2050. There are a lot of estimates out there, but this is one guidance, I would say, of looking at these different sectors and how much investment it will take to transition. The transition is in different phases for different things. I would say in a lot of it, like in electricity, we have solutions today, and in a lot of places, those solutions are cost effective to decarbonize those systems. And so it is more of an implementation phase. Transportation is just getting started, and there are hard to decarbonize sectors of our transportation, like our long haul, that we really haven't figured out. Buildings, we know what to do in a lot of that, and so it's an implementation. So there's a lot of different places that these energy systems are at, so we can continue to grow the energy services that we're providing and use less energy and less greenhouse gas emissions to do so. So the first one I want to point out is energy efficiency. Okay, so this chart was developed by a man named Amory Lovins, who was the co-founder of the Rocky Mountain Institute. It is a think tank that works on integrated design and other solutions to a lot of these challenges. And really, the main point I wanted you to get from this chart, as I describe it, is that energy efficiency is a really important aspect to providing energy services we need and using less energy to do so. It is the most cost-effective tool we have in our tool chest. And so what this chart is showing you, this is showing U.S. primary energy consumption. And this chart was made in the 1970s. And so at the time, this blue line is what the US government thought our energy needs were going to be. And Amory Lovins proposed that no, we'll get smarter about how we use energy. And he proposed what he calls the soft path, this black line. What we've actually done is this red line. And so the big point here is that energy efficiency has done a lot more to reduce the use of our fossil fuels than renewables, and that should continue into the future. So what do I mean by energy efficiency? Because sometimes it's confused with energy conservation. Energy efficiency is providing the same or even better service using less energy to do it. And so there's a lot of examples of that. I think lighting is usually the one that comes to mind for people, where instead of using an incandescent light bulb, you use an LED. You're still getting your lighting service, even a better lighting service, because it's not providing heat as well. So you don't have to provide cooling and things like that because it's coming off of your light, but using less energy to do it. And that is a key point to try to decarbonize. We need to do energy efficiency because it makes the decarbonization of our energy systems so much easier. So this chart was developed by McKinsey, looking at ways to reduce greenhouse gas emissions, so ways to reduce carbon emissions. And you can see everything here on the left. A lot of these are energy efficiency measures, and they are cost negative, meaning that implementation of these might have some costs up front, but you save money over time. And again, you should be getting the same or better service. We see this in green buildings, where people often have natural light instead of artificial light. They have more insulation, so their spaces are more comfortable, and you get increased productivity or increased happiness from people in those buildings. And so it's providing a better service using less energy to do so. And so this is our biggest tool. This is our biggest impact. The challenges with energy efficiency, so definitely not to say that it's easy to do energy efficiency. One of my favorite quotes from energy efficiency professor at Stanford was that it's not $20, it's 2,000 pennies. Energy efficiency does take knowledge of things like integrative design. It takes intention. It takes a willingness not to do things as we've always done it, but to try to find new ways to provide the energy services we want that will use less energy to do so. So it does take effort on the front end to implement energy efficiency. All right, the next one that we talk about in transitions usually is this transition and growth and renewable energy. Very, very exciting. When I really got into working in energy and energy industry, in the early 2000s, we didn't think solar was ever going to be cost effective. And now we're at a point today where wind and solar really are our most cost effective ways to produce new electricity. And so they're being installed at a rapid rate. And so this is a huge tool in the tool set for decarbonizing our electricity sector, is the growth in wind and solar as they become cost effective. And we see that. So this is just showing you new capacity additions in the United States, and solar is almost half of those. Transportation is more challenging. So this is just a chart looking at how efficient our transportation systems are from this excellent book, Resource Revolution, that I've put here in the bottom, showing that we're not very efficient about how we use our cars. It's a lot of capital investment to not using it very much. The motive power in our cars is not very efficient. Using a little heat engine in our cars is not a very efficient way to do it. And then even the infrastructure and how often we're using the roads and the bridges and everything that we put into our transportation infrastructure is not very efficient. And so there are ways that all of these are being addressed by new modes of transportation, by autonomous vehicles, things like that I think are going to change a lot of our transportation system. I just want to talk for a minute about electrification of our transportation system, because that automatically makes our transportation much more efficient. So using an electric motor instead of internal combustion engine or a diesel engine in your vehicle automatically makes it much more efficient. Electric motors can be 90% efficient. Our heat engines, are often more like 25 to 35% efficient. And so it is this automatic efficiency gain that you get, in addition to the other benefits of electrification of our transportation, one of them being that it really diversifies our fuels. And so you can see that when we're starting to get our fuel for our transportation system from the electricity system, we now have diversified where we're getting those fuels. It's not just from oil. And we see carbon emission benefits right away, or we can see them as we decarbonize the electricity system overall. And so that is a big opportunity for decarbonizing one of our biggest systems, which is transportation. So we're seeing countries do this all over the world. Norway has made a huge headway into adopting electric vehicles through some beneficial policy that they have in place. We see targets here in the United States for growing electric vehicles. And China has one of the largest markets for electric vehicles. So that does not mean that electric vehicles are not without challenges. So they work really well for passenger vehicles. It's harder for longer haul. Still a lot of work there. And then we have to think about where we're getting the resources for our batteries. And so those are all challenges that still remain in this aspect of decarbonizing our systems. I mentioned, batteries and battery storage. So we're not just using them in our vehicles, we're using them on our electricity system, making our electricity systems more resilient and better able to incorporate things like wind and solar. And as battery prices have come down along with solar and wind prices, we're really seeing that even a solar system plus batteries is cheaper than running an existing coal or an existing nuclear plant in the United States. And so they are able to bid in at a lower cost. And so we're seeing this dramatic transition happening in our electricity system. With the electrification of transportation, with the growth in residents and users providing their own electricity supply, like with solar panels on their roofs, with electrification of buildings, where we're electrifying appliances, stoves and heaters and things like that, we are going to see a whole new system where our transportation, our homes, and our electricity grid is all interconnected in new ways. And so there's a lot of growth there, and all of this is a transition that's happening and that is going to lead to more decarbonization. In the last couple of minutes, I want to just give a highlight for some transitions that are just on the cusp, that aren't really happening yet, but are poised to. And I would say you would see the increase of these coming. So geothermal is one. We've used geothermal resources for a long time to provide electricity, but there are new advents about the way we're getting these geothermal resources and making use of them. That means geothermal is going to grow and be a growing portion of decarbonizing our electricity systems. Hydrogen is upcoming. I would say hydrogen has been looked at as a way to decarbonize some of the more challenging ways to decarbonize our systems. And so you will see more and more investment and talk about hydrogen for fulfilling some of those challenging roles. And then even fusion. Fusion is getting a lot of attention right now, a lot of growth in startups, and looking at how we can advance this and have it be part of our solution. And finally, carbon capture and storage is getting a lot of attention. So how do we get to zero carbon or even carbon negative? Carbon capture and storage will be a piece of that solution. So finally, this is what our past has looked like for energy consumption. Definitely still in this oil and gas age, but we need to quickly move into this clean energy age. And we'll just have to see how fast we can make that happen. So with that, I'm sorry I wasn't able to answer your questions along the way. Hopefully some of the Q&A was answered as we went. And I'm happy to do what's next. So thank you all for your attention.
Thanks, Diana. I know we're at time, so it was a fantastic presentation and really appreciate you taking the time. We did have a couple questions that came in, so maybe we just focus on three short ones. Yeah. So one, do you have any predictions, or how are you feeling in terms of how optimistic are you about this transition that you laid out? Do you do you feel bold enough to say a few words right now about that?
Yeah, I'm happy to. So I will just say that I am a mom of 4. And so I feel like that drives me, that I need to be optimistic. And I think in the past, we've had transitions happen a lot faster than we thought. Cell phones, became ubiquitous a lot faster than we thought, and smartphones. We've transitioned, from 0 cars to millions of cars very quickly. I think we can do this with the right incentives. And so there are a lot of people around the world that are working on this, so it just makes me optimistic. And so I see that every day in students and things like that. The thing I'm most excited about, or just to know personally, is I've worked a lot on transportation. And so electrification of transportation is something I've seen come a long way over the last 20 years. And I'm really excited about the innovations there and the possibilities.
And maybe as a transition, as a kind of a final question is, so you do teach a class, Understand Energy, at Stanford. It is available for professionals to enroll in as a, we call a non-degree student, a non-matriculated student. You can find a link there. Could you say a little bit about that that class and how how you're thinking about it in terms of this larger transition, and maybe even as part of that, if you could speak a little bit more about Precourt and what you see your role in this larger, what you're doing as an educator in this area.
Yeah, absolutely. So the first thing on the course we teach, obviously we go into more into depth on all of these different aspects, and we go through each energy resource, so oil, coal, wind, geothermal, and really talk about all the aspects of it, the technical, the political, the regulatory, the environmental impacts, the potential. So you really get an in-depth dive to each of our energy resources. And then we also talk about cross-cutting things, so like transportation, buildings, energy efficiency, as those kind of topics. And so it is an intense in-depth to all of those, but it is designed to be for anybody. So you don't have to be an energy expert to come take our course. This is really introductory to all of these, where you don't need any prerequisites for our course. Precourt Institute for Energy. So this is the premier energy institute at Stanford. Has a lot of initiatives around research in a lot of these different areas, and is working closely with the Stanford School for Sustainability and how to get a lot of that research to scale and be impactful in the world. And so I would say we at Precourt have a responsibility for education, responsibility for research, and then a responsibility for getting that education research out to the world so it's impactful. And so all of those things are happening at Precourt and our partnership with the Stanford Doerr School of Sustainability.
Thank you, Dr. Gragg. We got a lot of questions. We didn't get to most of them, but we do want to make sure respect everyone's time who joined, and also Dr. Gragg's time. So thank you so much. We've got all those questions. If you answered the survey question there as well, we'll share them with Dr. Gragg. Maybe we have to do a follow-up webinar on some of these great questions that are coming in. So thank you, everybody. We really appreciate you being here today. Thank you, Dr. Gragg.
Yeah, well, thank you, everyone.